There are so many LLMs today, from the top labs like OpenAI, Anthropic, Grok, Gemini, and there's only more. It seems like there's a new one launching every week. And it's becoming harder and harder to know when to use which model and what for. What are the models actually good at? Benchmarks really only tell you part of the story and are notoriously, gamed by these companies. And so it becomes really hard when you're an individual or working in a team to answer the question of like, hey, I'm just writing. Can I use O3? Should I use 4.0 or Anthropic? I'm writing code. What should I do for that? And like a lot of times I feel like people are kind of overkilling it by, using O3 for everything. And so there's this really cool paper recently called Arc Router that looks to kind of solve this problem of like routing the correct query to the correct model. It's a really interesting kind of way to do things. It's based on user preferences. And so we're going to jump right in. First, talk about the different ways that you can kind of use LLM routers. And I'm not talking about stuff like OpenRouter that kind of just proxy the request to the different models. That's a great service. This is really about aligning LLM to use case. And so one way to do that is like an intent embedding based type of router, where you create embeddings for each user message and you run like a semantic similarity vector search against a fixed set of topics. So you see a user message, you do a vector search that says, hey, this is a billing one, this is math, this is writing. And then you make your decision based on that to send to a certain model. So in this case, like we're really talking about probably in like a generative interface. Like ChatGPT isn't going to integrate something like this, but that's kind of the use case to think of. Like when I'm sending this query, how to route it to the best model to get the best output. You could have this in your application as well, depending on what you're building. And so it's pretty easy to get up and running, but it requires retraining and any time you're trying to like redefine the intents or add new models. And so it's a little bit hard to keep up with. Another is like a cost performance kind of based router. So when you use the benchmarks or kind of cost data to train a router in some way, that decides basically like, hey, can a cheaper model be used for this, or do we need to use a stronger, more expensive one? And that decision again could be based on benchmarks. Or you could do it based on costs in a way as well, to kind of blend those together. And so this doesn't really account for like subjective criteria. A lot of the benchmarks are great, but they don't always align with human preferences, as we see from like LLM Arena and WebDev Arena. Rule-driven routers, so hard-coded if-else logic that maps queries to models in some way. That's not like a vector search. And this is fast because you'd just be doing it with code, so it'd be ultra-low latency and like transparency, but like hard to maintain as it scales and having if and else kind of scattered throughout the file. And the last one in what Arc Router does is basically a preference aligned router, which is basically you write policies in plain English that says, hey, for like these type of tasks, use this type of model. And then you use their Arc Router model to route those tasks. So there's a call in between you and the LLM to Arc Router that will basically tell you which type of request this is, and then we'll direct it to the right model based on the rules that you set. So we're going to look at it, but it's human interpretable. You can adapt it just by adding a couple lines of text, and it's really easy to get up and running. And so again, this is a model in and of itself. It's on Hugging Face. It's 1.5 billion parameters. It's a fine tune of a quen. And it routes user queries to certain models based on whatever your policies are. So no benchmarks, no if-else rules. Each policy is a simple identifier and description tuple. So for example, legal review, that would be like the identifier, and a little bit of the description of that task. So analyze a contract clause, blah, blah, blah. Then there's a separate lookup table that maps each identifier to a model. So for legal stuff, do GPT 4.0. This description is just to better help the model have context of what the actual task is. As I mentioned, it's a quen model, and is able to get to pretty high performance. So on the benchmark for these classification tasks that these researchers ran, it was at 20.7. They did fine tuning, got up to 93, which is basically on par or better than all of the kind of top models at the time. And so something that would be coming to mind and could jump to mind for me is like, okay, this sounds good, but how much latency does it add? And I think on average it's about 50 milliseconds of latency. Let's see, 50 milliseconds of latency. Interestingly, they're saying that Gemini Flash would take 510 milliseconds of latency, and Claude being 1400. So it's super fast. 50 milliseconds is basically unnoticeable. And so at its core, here's how it works. As we talked about before, you define your policies. So identifier and description, and then you have this lookup table. So when the model says, hey, this is a code gen task, when Arc Router says this is a code gen task, it notes to then route that request to Claude Sonnet. And something that they note is that this can be used throughout the conversation. So you can imagine when you're chatting, going back and forth, you're running this every time. You can pass the message history if you want. But this means that you could switch mid-conversation automatically, which, may not seem like it's relevant, and it might not be used all the time in terms of a conversation changing. But you can imagine a situation where you go from like generating data to analyzing data, or from generating data to writing code about that data. You might want to use different models for that. And so that's another benefit of Arc routers that can change on the fly. And so the router prompt is here. It has the policies, conversation history, the new user query, and some extra instructions, which you can see below. So your helpful assistant designed to find the best route. Here's some information. Here's the conversation. Here are the instructions. If the latest intent from user is relevant or user intent is fulfilled, respond with the other route. Analyze the route descriptions, find the best match, respond with just the route name, right? Because we're going to take that and pass that into our lookup table. And then that's it. It takes the user prompt, it outputs one of the policy identifiers, and then it goes to the lookup table, and then that sends the request to the relevant LLM based on that identifier. And so since the policy lives in the prompt itself, it's really easy. The upshot is it's really easy to update these, especially as new models come out, or if your preferences change as the models change, if there's any drift or something like that. And so really fun. Again, it'd be fun to kind of hack a project together that tests this and kind of goes through the conversations and see how it switches. And you could imagine setting up an automated system to do this as well if you had like an open source version of ChatGPT running, such that you could then make sure that anytime any one of your teammates is interacting with AI, it's kind of doing it in the right way. We see a lot of times that users will have a bad experience with AI, maybe potentially because they're using the wrong model, or it's overkill for what they're trying to get done. And it can be confusing, right? Like all the names, the different models, it can make people's eyes really glaze over. It does for me, and I'm pretty deep in this world. And so that's what Arc Router could potentially solve as well. So a lot of interesting stuff here. I hope you enjoyed this one. We'll have a bunch of links below to the projects, resources, everything along those lines. If you want to get started with it, try it below. See ya.